Today we are going to discuss about enzyme immobilization. So upon completion of this topic, all the students will be able to explain what is the need of enzyme immobilization, what are the different methods, and what are its application in biotechnology. So enzymes, so enzymes are biological catalysts that will promote the rate of reactions, and they are not consumed in the reaction. Okay, they may be used repeatedly for as long as they remain active, but in most of the process, enzymes are usually mixed in a solution with the substrate, and as the enzymes are mixed in the solution, they cannot be recovered after the reaction. That means each time the enzymes that we are used for the reaction is wasted. Okay, so enzymes means they are biological catalyst. Along with the substrate, we are adding enzymes in order to convert the substrate into product. That means in order to increase the rate of conversion of substrate into product. Okay, so while we are using enzymes, the enzymes are mixed with the substrate, so that what happens, the substrate with other reactions, or some reactions occurs, the substrates are converted into products, so that with the help of enzymes, the rate of the reaction, the speed of the reaction also increased. But each time we are using different types of enzymes. Okay, so now we understand that in order to recover the enzyme, some method has to be implemented so that the wastage of enzymes in each reactions can be reduced. Okay, so enzyme mobilization means it is a method of confining the enzymes to a solid support so that the substrate can be passed over this support and will be converted into a product. Okay, so that process is known as enzyme mobilization. That means here we are not mixing the enzymes with the substrate. Rather than that, what we are doing is that the enzyme is first linked with a solid support, and over to the support we are adding the substrate solution, so that the substrate solution will passed over this solid support containing the enzymes and will be converted into product. So next time if we want to use the same enzyme for a reaction, the solid support it can be taken out from the reaction vessel and it can be put into the another reaction. The next substrate can pass over it and can be converted into product, so that the enzyme can be recovered after each reaction. The enzymes can be recovered and can be reused for the other reactions. Okay, so immobilization, the word meaning, the restriction, that means stopping the movement of enzyme. That means the enzyme's movement is stopped by linking or confining the enzymes to a solid support. Okay, so what is the need? Okay, so first of all, by enzyme mobilization, we can protect the enzymes from activation, degradation, retention of enzymes. That is, it's one of the most important application. The enzymes can be retained, it can be recycled, so that with the same enzyme itself, a lot of chemical reactions can be possible. Otherwise, what happens if one enzyme is used with one substrate? It cannot be retained since the enzymes are mixed inside the substrate solution. But if it is confined to a solid support, once one reaction is over, the solid support can be taken out and it can be placed into another reaction vessel. Then the substrate can be passed over it and it can be converted into products, so that wastage of enzymes will be reduced. Thereby cost efficiency can be increased, stability can be increased, and this method can be used to formulate controlled release agents. And if whenever if we feel to stop the reaction rapidly, just we can remove this enzyme from the reaction media. And also, in order to develop multi-enzyme system also, these enzymes can be used. So what are the ideal carriers? So we have already said that enzyme mobilization means we are confining the enzymes with a solid support. So this solid carrier should possess some properties. It should be inert, physically and strong, cost effective, regenerable, and reduction in product inhibition. And different carriers that we can use: inorganic, organic, and organosynthetic. Inorganic examples include silicon dioxide, porous silica, glass, mineral materials such as selenite and xenonite. All these carriers have high pressure stability. Sometimes it may undergo abrasion. That is one of the disadvantage. Organic natural carriers, it has compatibility with proteins, cellulose derivatives, dextran, polysaccharide. Then the combination of synthetic and organic carriers, they have high chemical and mechanical stability, polysterenes, polyacetates, acrylic polymers, etc. Then coming to the methods. So there are two methods: physical methods and chemical methods. Physical methods usually includes adsorption, entrapment, and encapsulation. Chemical methods mainly covalent binding. This covalent binding either through support or cross-linking can be possible. So the first immobilized enzyme was released in 1969 in Japan. The first immobilized enzyme used was aminocyclase, and this aminocyclase was the first immobilized enzyme that we have developed. And this aminocyclase was the enzyme which is produced by a fungus, Aspergillus oryzae. So coming to the first method, that is adsorption. So adsorption means it involves the just only a physical binding of the enzyme with the carrier metric surface. Okay, the carrier we already said organic carriers we can use or inorganic. The main process of interaction is that hydrogen bonds or van der Waals forces. Examples of enzymes that can be immobilized by like this here: catalase and invertase. Method. So the main method is we are just mixing the enzymes with the carrier in a bioreactor. And this method can be carried out by different process: static process, in which we are allowing to mix enzyme and the carrier just without stirring. That means in static process, static means rest. That means simply we are mixing enzyme and carrier without any stirring. Dynamic batch process means carrier is placed in the enzyme solution and it is mixed with the help of a stirrer or agitators. Reactor loading process means the carrier is placed in the bioreactor, then the enzyme solution is transferred to the reactor with a continuous agitation. Electrode position process means the carrier is placed near to an electrode in an enzyme bath, then current is put on. So enzyme bath is prepared, into that an electrode is placed, and near to that electrode a carrier is placed. And while the electricity is put on, what happens? Due to the presence of this, under the influence of the electric field, like enzymes will migrate towards the carrier and deposit it on its surface. So these are the four methods for adsorption. Advantages: simple economic, limited loss of activity, the enzymes can be recycled and reused. Disadvantage: low surface area, exposure enzyme, since the organic carriers and maybe undergo microbial attack, yield is very less. And it has been noted that for this physical binding, the carrier's particle size must be of small. Okay, and that is 500 to 1 millimeter in diameter. That only should be the carrier's particle size. And one of the most important advantage of adsorption method is that there is no pore diffusion limitations, since the enzymes are externally supported. That means enzymes will not get leached out from the surface out from the carrier. Okay, since they are externally immobilized on the support or the carrier. Next is ionic binding. It is a type of adsorption where we are using the carriers we are used are ion exchange resins, which are positively or negatively charged. And during this process, maintenance of pH, ionic strength, etc. is required. These are the examples of enzymes that are immobilized by adsorption and ionic binding. Coming to the applications, the mobilization of enzymes can be used to produce antibiotics such as ampicillin, amoxicillin, penicillin, and cephalosporins. Different types of steroids such as hydrocortisones, prednisolones, etc. can be produced by the immobilization of certain organisms. And not only enzymes, certain microorganisms can be also immobilized. So steroids are usually produced by immobilizing certain microorganisms. Then amino acids, production of acids, and it is also has some other in application, that is biosensors, enzyme immunoassays, in enzyme thermometers. These all are the devices that is used for some analytical purposes in the biomedical field, and in all these devices immobilized enzymes are usually used. Thank you.